is an example of a project that uses the LCD. As you can see, there's an LCD here, or liquid crystal display, and I connected the GND to the negative or to the ground row of the breadboard. The VCC of the LCD is connected to the positive row of the breadboard. The VO of the LCD is connected also to the ground. The RS is connected on the breadboard on A4 or anywhere on the breadboard, wherever you want it to be. But for this particular example, I put it on A4 of the breadboard. And then the RW is connected on the negative row of the breadboard. The E of the LCD is connected to A6. DB0 up to DB3 is not connected. DB4 is connected on the breadboard on A11 or wherever you want it to be. DB5 on A12. DB6 on A13. DB7 on A14. LED anode or LED plus is connected to the positive row of the breadboard, and the LED cathode or LED minus is connected on A16. Now if you will look closely here, A16 or the LED cathode is connected on the resistor here, which is on D16, and on F16 or the other side of the resistor, it is connected to J16, which is connected to the negative row of the breadboard. By the way, this negative row is also connected to the negative row at the bottom. Therefore, all of these negative rows at the bottom or negative row at the bottom is connected to the negative row at the top of the breadboard. Now, the positive row of the breadboard is connected to positive 5 volts of the Arduino. As you can see here, this is positive 5 volts and it's connected to the positive row of the breadboard. And this is where this LED anode is connected, also the VCC or the power of the LCD. Now, the RS, E, DB4, DB5, DB6, and DB7 are connected here on row E, number 4, E4, E6, E11, E12, E13, and E14. So these wires are furthermore connected to digital pin 12 for the RS, digital pin 11 for E, digital pin 10 for DB4, digital pin 9 for DB5, digital pin 8 for DB6, and digital pin 7 for DB7. So these are the connections. Now the ground or the GND from the Arduino is connected to the ground row at the top of the breadboard, while the digital 13, as you can see here on the red wire or red connecting wire, is connected on the anode of the LED here, which is on F21 connected to J21. So the anode of the LED is connected on digital pin number 13, while the ground is connected on the upper row ground or upper ground row of the breadboard. And the resistor here is connected on that ground. And as I have said or mentioned, the resistor here is connected on the LED cathode of the LCD. So these are the connections. Now for the program, let's click on the code. And you will see here the first 3 rows are just comments about the title of the project and the ERC Tipsknowlogy and the date today, May 7, 2022. In line number 5, we need to put this liquid crystal.h because this is the header file. Okay, let's put a comment here. Okay, and the line 7 has liquid crystal, and then we use the LCD 12, 11, 10, 9, 8, 7, which refers to the connections of the digital pins. 12 on RS, 11 on E, DB4 is 10, DB5 is 9, DB6 is 6, and DB7 is on digital pin 7. In the setup function, this is where we declare the LCD begin 16 to, which means we have the LCD with 16 columns starting from column 0 to column 15, and we have 2 rows starting from row 0 to row 1. Then, as we have mentioned before, pin mode 13 output refers to the digital pin 13 with the LED as your output. In the loop function, you will see here that the LCD cursor is first set at column 2, row 0, before we displayed the message LCD project 1. After that, we position again the cursor on column 0, row 1, and then before we printed the message ERC Tipsknowlogy. And after displaying these 2 messages, we made the LED to blink, turn it on for 250 milliseconds or a quarter of a second, and then turn it off for another quarter of a second. So that's it. This is our program. Let's start the simulation again, just to see the output. Click Start Simulation, blinking. Thank you so much. I hope the sample of LCD project will help you in your future projects. Thank you. Please like and subscribe and share our video to support ERC Tipsknowlogy. Until next time.